Am I audible to you? Please respond.
Yes, sir.
Yes,
Oh,
sir.
okay, thank you very much. Now we are going to start our classes. Yes. Before starting the class, let us have some review of what we have studied in last classes. Yes. What we have done in the last class. Either what is screen is on your screen? Whiteboard is on your screen or not?
Yes, sir.
Okay. Okay, now see what we have done last class. We have studied the one of the plastic processing, that is plastic product processing process. First, it is extrusion. We discuss about the concept of extrusion. Then we discuss about the machinery used in the extrusion, machinery and tools. We discuss about the application of this process. While studying the machinery and tools, we discuss about the process setup, here process setup, we told that there is the driving mechanism, then we shall throw in some extruder. The extruder, that is mean a screw press. The driving mechanism consists of the motor, then transmission, motor trans plus transmission give us the driving mechanism. The extruder, we have said that is, we power the different zone of extruder. Additional setup for the breaker plate, and screen. Screen. We told that screen is used for removing the solid materials, while breaker plate is used for uniform the flow. That is, from the circular flow, it will convert the flow in the linear flow. So that is the function of breaker plate and screen. After that, we have studied the construction of the screw. The construction of the screw, and here we told that three zone: feeding zone, then melting zone, and metering zone. We have the studied the constructional elements of the screw. We identify the some dimensional parameter of the screw extruder. First, it is barrel diameter. Then we call that channel depth. Screw pitch. Yes, barrel screw pitch, length of the screw. Length of the screw, and other parameter of flight angle. This dimensional parameter will be used for calculating the flow pressure, and other that numerical parameters of the extrusion process. We have already also discussion about some formulas. It will be direct flow, then be backflow, direct flow, then the backflow, resulting flow, Q maximum, P maximum, die diameter, die length, dd, ld. So this is the parameters found, and also we have seen the shape factor. So these are the formulas what we are going to study. We shall repeat it today for our own benefit. Yes. Now today we are going to study two things. One is called the extruder characteristics. Number two, extruder characteristics. Number two, we are going to study die characteristics. We shall study the deduction of the formula, derivation of the formula. For these characteristics, and also we shall solve some numerical problem related to extrusion process. Okay, so that will be what we are going to study today. Okay, let us start our study. For that purpose, I am going to share my slide. I think I already posted these slides which you required for this extrusion process in the Google Classroom. Okay, so I think if you have printed it, you take it in front of you. Okay. Now see, we have told that we are going to now. Okay, before that, let us review the formula what we have studied. See, we have studied formula for the direct flow, for the direct flow. So direct flow is the flow which will tends that with the how the material melting material flow per unit time, and what happens if there is no die, that is if there is no pressure, back pressure, that is it is open, so it will go for. So this direct flow will depend upon the barrel dia, it depend upon the RPM of the screw, it will depend upon the channel depth, and it will depend upon the flight angle. Okay, it is flight angle. So this is our direct flow, and this formula were, but we can reduce the formula, but we are not going to reduce it. We shall directly see that formula. Okay. Then I already told you that this flow is when there is no die. That means it is the maximum flow. That means flow, no restriction is there. Now, other nature that is we are not going to say it. But when we shall place the die, what will happen? There will be some restriction coming on the way, because the restriction energy will go through need to, for passing the materials through the die. For that purpose, the flow will be reduced. So flow will be reduced. But in generally, in conceptually, we can tell that some material will come back. Yes, some material will come back. So it is generally called that this is a backflow. If it is a direct flow, and this is our backflow. Again, we are not going to reduce the formula, just we will set the formula here. Okay. So this backflow can be calculated by using this formula. So where P is our back pressure, this pressure will depend upon the die. Yes, upon the die. Okay. Then barrel dia we know, DC we know, A we know, and is a mu or eta. It may be mu, or sometimes it is called as a eta. Then whatever may be indication, it is our viscosity. It is our viscosity. Okay. So this viscosity, and L is our screw length. We see L is our screw length. We have already discussed while starting the construction of the screw. This screw length. Now see, this is our if we have the forward flow or direct flow and back flow or resistance, there is a reduction of flow due to resistance, we can find out our resultant force. Yes, Qx is equal to Qd minus Q. It is normally called the operating flow or normal flow. Yes, operating flow, normal flow. So I am now putting the value of Qd and Qb. We are getting the formula for general flow for the flow. Okay, flow. Now, one thing we can see now. See, maximum flow will be when there is no restriction. That means there is no back pressure. That means it will be equal to the direct flow. Yeah, that Q max is equal to direct flow. Okay. Here also minimum flow, what is called the zero flow. Zero flow will be when Qd will be equal to Qb. Yes, when Qd will be equal to Qb. So putting the value of Qd and Qb, we can find out the value of P maximum. Yes, we can value of the figure. But means here in place of P, we shall put the P maximum. And in place of Qd, we can put the P maximum. And after having the that is numerical setting, we can get this formula. So this is the formula for Q maximum. This is the important two parameter which will be required for find out screw characteristics and the die characteristics. So that is the thing what we have done. And last we discussed just today, we have repeated. The one of the important factor is the unit factor. Okay. So let us see what is our Qd unit. Millimeter square divided by per minute and unit per minute. Then millimeter. So we are getting a millimeter cube per minute. So Qd is the rate of flow. Yes, Qd is the rate of flow per unit time. Yes. So it may have a different flow, meter cube per minute or meter cube per second. And so whatever may. So we must be careful about the unit. Yes, about the depending upon which unit we are placing here. Similarly, you will see that QB unit. Yes. QB unit, see, remember pressure will be given as a Pascal. D is a millimeter. Then millimeter cube divided by mu unit is Pascal second. Yes, Pascal second. And L is equal to, if you put in millimeter, then we are getting as also millimeter cube per second. We can convert it to millimeter cube per minute multiplied by 60. multiplied with 16. So that is the formula we shall give it. You can memorize this formula. I think it is better to memorize the formula, or otherwise, if as it is complex, maybe this formula will be given to you during the exam. Okay. Now let us go for our next slide. Yes. Now we are going. We have already told today is one of the topics we are going to discuss. It is about extruder characteristics. Yes. The extruder characteristics is nothing but a relationship between the flow and pressure. So if we are thinking without die extruder, we can say, we can find out that if the how the flow will affect the how the flow will be related to the pressure. Now, for that purpose, let us see our formula for. Now, it is found a formula for a extruder. See, Qx is equal to 0.5 here pi formula. I think so. Let us copy the formula from there. Pi d square and dc. Pi d square and d pi square and dc into sine A into cos A. Here, cos A. Minus the formula for P maximum. Yes, P pi d dc cube. P pi d dc cube sine square A divided by twelve mu L. Mu L. Okay, for a particular extruder machine, this is a constant. And so you can write Qx is equal to, and C it is equal to Q maximum. So it is a constant, so we can write Q maximum minus, yes, minus, what is this? Here it is backflow. So if we can write it in other way. You will see we can write it in this way, that it is equal to P by P maximum. It will be equal to P by P maximum. Yes, P by P maximum, it will be given us. Okay, you will see it will be give us P by 1 into Q maximum. You can write, or you can say that means one thing we can write it here. If we shall write it, Q is equal to Q maximum, therefore plus P into the P into, okay, not this, just a minute. Say, if we convert a Qx will be equal to, if this value 0.5 pi d square and dc sine A cos A, you take it out of the bracket, yes, then here we shall get what? 1 minus 3 pi d dc cube sin square A divided by 12 eta L into, that is divided by this value 0.5 pi d square and dc sin A into cos A. And you will see we shall get it as it is the that you will get it as 1 minus P divided by P maximum, and it is our Q maximum. So Qx will be is equal to Q maximum 1 minus P by P maximum. So this is our characteristic equation, and it is constant for a particular extruder, for a particular extruder. That means this is called. So depending upon the P, Q max will be given. Now, if you want to express this in by the characteristic that is graphically, then see, if our P is equal to 0, Qx will be Q maximum. Yes, this point. Is if our Qx is 0, then what will happen? Then we shall get the P will be equal to a P maximum. So this is the this is our extruder characteristics. This is our extruder characteristic. Am I clear? Okay. Now, I think so. You have already having the idea about the extruder characteristics. Yes, to the characteristics. Then we shall go for our die characteristics. Yeah, die characteristics. For that purpose, let us have our whiteboard. It will be better to have the whiteboard. We have seen the extruder characteristics. We find the what is that means Q is equal to, because it is a relationship between Q is a function of P pressure. Yes. So how we already did formula? It is equal to Q maximum into 1 minus P divided by P maximum. 1 minus divided by P maximum. So if we indicate the anomaly, the y is equal to, we can see that it is a straight line. So y is equal to mx plus c. Yes, a straight line equation where m is equal to, you see, minus Q maximum by P maximum, and C is equal to P by P maximum. Now, if we draw the graph, that means C, P by P maximum. Here is our P. It will be our P maximum. It will be Q maximum. So this is the slope of the equation of the straight line. M is equal to or minus Q maximum by P maximum. So you can see as it is minus, it is the reduction side, and C is equal to our C is equal to Q maximum divided by C will be equal to Q maximum. So it is our Q maximum from here. If you convert it, you will get this value. Yes, you will get this value. Okay. Now that means extruder characteristics we know. Now we shall come for the die characteristics. So die characteristics, it is a relation between flow through the die and pressure and the pressure. Okay. Right. That means if we draw the curve, this is our P, this is our Q, and it is found that this Qx will be equal to Ks into P. Ks into P. So this equation is in a straight line going through the center. Through the center. Oh, this straight line is equal to under. So Ks, it is called the die shape factor. So this will depend upon the die shape. Yes, it will upon the die shape, and also you will see for circular, we have given a Ks is equal to the slide. You will see for the circular it is given. Now, in generally, what is that? See, it is our die characteristics. It is our die characteristics, and here is the Q maximum, and it is our extruder characteristic. So I see what will be now operating flow. So that means the operating that is flow in the extruder must be equal to flow in the die. Right? When these two flow will be equal, then that will be the operating point. Now in our case, that this point will be the intersection point between these two characteristics. That means this will be known as a operating pressure. This will be known as a operating flow. Operating pressure and operating flow. Then I think so now that means flow and the pressure which will be during the operation will name as a operating pressure and operating flow. So that is the thing what we are going to have. Okay? Because of the flow in the extruder must be equal to flow in the die, and in that case only the extruder will operate. In the only extruder operate. Now see, I am just repeating. We know what is our extruder characteristics, and now we know what is the die characteristics. This is our die characteristics expressed in the equation. Now, what we can do? If we experimentally find the flow, relation between the flow and the Q, we can easily find out the value of Ks. Value of Ks. For particular shape, we can find out the value of Ks, and that Ks may be given as a modeling. After modeling, you can give a formula. We shall give a formula. Okay. So that is the thing what we are going to start. Now we shall going for solution of numerical problem solved. Numerical problem. For numerical solution of the formula, that is me. I already give you the slide. I shall upload the slide in the I already uploaded the slide in the Google Classroom. Okay. That means, see, now what I have told thee for circular shape. For circular shape, Ks can be calculated theoretically by using this formula. Okay, that is the thing what you have to know sometime for our numerical solution of the problem. Now let us have some numerical solution of the problem. This will come. Okay. The first solution, what we have done. So this is a problem. What the problem? The diameter of an extruder barrel is 65 millimeter and its length is 1.75 millimeter. The screw rotates at 55 revolution per minute. The screw channel depth is 5 millimeter and the flight angle is 18 degree. The head pressure at the die end of the barrel is 5.0 into 10 to the 6 Pascal. The viscosity of the polymer melt is given as 100 Pascal second. Find the volume rate of the plastic in the barrel. Okay. So before going to solve this problem, yes, I shall give you one of the sequence of solution of the technical problem. So it is my solution of the problem. I again tell you, it is not mandatory for you to follow this sequence, but my experience shows that if you follow the sequence, possibility of mistake reduced to minimum. Yes, minimum. Okay, now let us see solve this problem. I think so. You have this slide. I am going to whiteboard for reduction the formula for the formula. So you will help me by giving some parameters and the formula. Okay. Okay. So while solving the problem, first step what we are going to take is number one, we shall enlist the given information. Yes, what is our information given? Now, in the problem we have already studied, first thing it is given a barrel die. Yes, what is given barrel die is given as, if I mistake, please correct me. Okay, 65 millimeter. Length of the screw is given as 1.75 millimeter. Sorry, not millimeter, it is meter. Then RPM N is given as 55 revolution per minute. BC channel depth is given 5 millimeter. Flight angle A is given as 18 degree. Then pressure is given as 5.10 to the power 6 Pascal. I am requesting you, I am asking you to note this solution of the problem in your notebook. Because of that, you need it for solution of the problems or in the assignments. Okay. Now it is given. Now what is it is first. Second thing I shall tell you what required to calculate. So what we have to record to calculate? It is given What is it? They calculate the value of flow. That means Qx what? So these two is giving us the information what is given in your problem. Yes, what is given problem. And I think so. If you can write this thing, you have already, I think that you have understand the question. You understand the problem. So first of all, be careful while you writing this thing. All information must be taken from your problem. Yes, from your problem here. Okay. Now here people going to the next step. I am thinking you 65 millimeter, meter, revolution per meter. We shall try to convert all the things, yes, all the things in a same unit. Say millimeter, meter, here is millimeter, Pascal. So let us see for length, we can make it all millimeter or meter. If we are converting in meter, then I shall take it, it will be 65 into 10 to the minus 3 meter. It is already in a meter. It will be equal to 5 into 10 to the power minus 3 meter. Okay. So another thing is they are given, mu is given 100 Pascal second. Okay. Then is record to calculate Q. Our next step, see, remember, while writing the given, you have to see the uniform unit. If there is all the unit. Here is Pascal, here is Pascal. So pressure unit, you are taking Pascal. Time unit. The time unit here is second. Here is minute. So either we shall convert it all in second, or we shall convert it all in minute. Yes. So if you want to convert it in minute, or in, say, if you convert it in minute, then it will be 55 divided by 60 revolution per second. Okay. Or what are the you remaining it in minute? You can convert it into minute. Then it will be equal to 100 divided by 100 multiplied by 60. 100 multiplied by 60 Pascal minute. So that thing we are going to come to. Yes, understand. So you can take both options, either millimeter or meter, or you can take either second or minute. Then what our result will be accordingly. This result will be accordingly. So one of the important thing is unit. How to find out the unit. Okay. Now we shall go for our third stage. Here we shall formulate. We shall find out the formula to find out our record calculation, for record calculation. Here we are going to calculate the 2x. What is the formula available for calculating the qx? We know it is qd minus qb. Now both qd and qb is not known to us. So we have to calculate qd and qb. So for this purpose, we shall calculate the qd. We know the formula qd 0.5 pi square d square. Please help me. Someone is help me. Pi square d square. What is the formula?
Sir, n dc sin a cos a.
And dc
Sin a cos.
Sin a
Cos a.
Okay. Thank you very much. Now see, d is known to us. Known to us. N is known to us. Known to us. DC is known to us. A is known to us. That means we can easily calculate the QD by placing the numerical value of this. Then we shall come to our QB. Sir, please help me for formula for QB. Hello? Hello. For formula of QB. What is the formula for
Sir,
QB?
P pi D
P pi
D
D
C Q
D D এর পরে n, তাই না?
no
Ah.
sir D
P pi D তারপর কি?
sir DCQ sir channel
Good.
depth cube
Or DC, yes, channel depth. D into DC cube.
जी sir
DC cube তারপরে
sin square A
sin square A divided by
12
12 mu
mu L
mu L. Yes, formula. Okay. Now see, P is known to us, D is known to us, DC is known to us, A is known to us, mu is known to us, L is known to us. So this value we can calculate. So that means QD and QB may be calculated by using the formula. Okay. And if QD and QB is known to us, QX is known to us. Okay. Then fourth stage is our calculation. So here no calculation you will do. Only write the formula. Yes. Next we shall for the calculation. The calculation in generally I shall say you will start from the bottom. Yes, from the bottom. So first of all QB, we shall put the formula, put the value and have a numerical value. Yes, what will be unit of this value? See, if we put the P as a Pascal, second or minutes, let us see put it in minute. Okay, Pascal minute. Remember here my Pascal minute, then pi don't have any unit, D have the, let us put it in meter, then DC will be in meter cube, and sin square A don't have any unit. Here mu have a Pascal, sorry, P is a Pascal, not minute. Mu has a Pascal minute. Okay, and L as also meter. So what we are getting it? See, Pascal will reduce, and we shall get meter reduce. We shall get it is equal to meter cube per minute. Am I clear? So this thing is we will to calculate, because most of my students have problem with this unit. Now then we shall calculate the QD. Then we shall calculate the QD, and we shall put the value and have a numerical value. What will be its unit? See, meter square, n is equal to per minute. Revolution, I don't have any unit. It is unit rotation time per minute. Then we shall have our DC, that means meter, and sin A cos A don't have any unit, and we are getting it meter cube per minute. Why I am concerned? Because of if this two unit is not same, I cannot just QX will be equal to QD is known to us minus QB is known to us, and the unit we shall get, and unit will be, because both of them are in meter cube per minute, so unit will be meter cube per minute. Yes. Now this is the fourth equation. Now fifth, you will describe the answer. So this answer may be numerical, may be a logical, or may be explanation. Okay, this discussion. So here what will be discussion? That flow QX will be equal to some numerical value into meter cube per minute. So I think so. We have these 5 states. for calculation the limit. This is simple problem, but when you will get a complicated formula or complex problem, then you will see this. If you follow this sequence, you will go ultimately to the result. Yes, ultimately to the result, and I think so. Examiner will be happy with you. Okay, and possibility of error will be reduced to 0. Possibility will be reduced to 0. Okay. Now, next we shall go for another problem. So, what is this problem? This is another problem. So, I think so. You will note again the parameters. You note the parameters. So, what is given? We shall go to the whiteboard. Before that, please note, given D is equal to 75 millimeter. Then N is equal to given 1 revolution per second. Yes, N is given as 1 revolution per second. Then DC is given 6 millimeter. Flight angle is 20 degree. Head pressure is given 7 into 10 to the power 6. The length of the barrel is given 1.9 meter. And eta is given as 100 Pascal second. What we have to calculate? Plastic made has shear. What to calculate? We should calculate here the volume flow rate. That means Qx. Yes, volume flow rate. We have to calculate. And also second stage of the problem is that if eta is 100 mil, we have to calculate the Q maximum. We have to calculate the P maximum. We have to calculate the K as shape. If the diparameter is given, what is the diparameter? Is 6.5 and LD is equal to 20, and C value of Qx and P at the operating point. Yes, that is QO and PO. So now I shall go to the whiteboard to solve the problem. Please, you have to help me by giving the data, because while I am giving the whiteboard, I shall not have any data present there. So let me note what is given. We have given the barrel dia. Yes, it is barrel dia D is equal to 75 millimeter. Please correct me if I am wrong. And is given as 1 revolution per second. Then channel depth is given as 6 millimeter. Flight angle A is given as 20 degree. Pressure is given as 7 into 10 to the power 6 Pascal second. Yes. No, sorry, it is Pascal, not second, okay, Pascal. And mu or eta, it is given as 100 Pascal second. Yes, it is our given. So I require to calculate through the L, I drop the L. L is equal to 1.9 meter. The required to calculate, you got to calculate first of what? Number one, it is a QX. What is that? Then we have to find out the Q maximum. We have to find out the P maximum. We have to find out the Ks for a circular. See, for circular die is given as what? Diameter of the die opening is given as 6.5 millimeter, and length of the die is given as 20 millimeter. 20 millimeter. So we have to find out the Ks, and we have to find out the QO and PO. Okay, that is the thing we are going to calculate. Yes. Okay, let us have our third stage. Write the formula. So at first stage we shall have that determination or calculation of Qx. Yes, we know Qx is equal to QD minus QB. So I QD, you will write the formula 0.5 pi square d square and whatever may be. Okay, then we shall write the QB. We shall see all the parameter is there. If now there, we have to calculate that parameter. Remember, now I think so all the parameter is there. Then QB, you will write the formula. Okay, QD QB. So that is the for QX. Then our next stage is to find out the Q maximum. Yes. So we shall write the formula for Q maximum. I think Q maximum is equal to QD, and QD is now already known to me. Okay, Q maximum known to me. Now P maximum. P maximum is formula is there. Yes, P maximum formula we have already there. So I will put the formula and see if all the diameter is there or not. Okay. Our next stage to calculate is Ks. We know Ks is equal to QO divided by PO. Yes, QO divided by PO. Q by Ks is QO by PO. Or we can have the for circular dia, we have given the formula for QS. What is the formula? Can you give me the formula? It is some for can you tell me the formula? Yes, my dear friends. Or I have to find out the formula. Yes, the formula, please note, yeah, it is in a slide. Okay, again I am formula for Ks. Formula Ks is equal to Ks is equal to pi d to the power pi d to the power 4 divided by 128 mu LD. Okay, so we have already okay. Now see what we are here. So Ks formula, let me write, is pi d to the power 4 divided by 128 mu LD. So DD is there, LD is there, mu is there. We can easily calculate the Ks. Yes, you can easily calculate the Ks. Clear? So it is our calculate the Ks. Okay. Now next thing we have to calculate what is that? We have to calculate QO and PO. Okay, QO and PO. So we can write it PO is equal to Ks into sorry, PO will be equal to QO divided by Ks. Now Ks is known to us, but QO is not known to us. Yes? Q0 is not known to us. How to calculate the Q0? Yes, how to calculate the Q0? The Q0 is operating pressure. We know if we put the value of Qx, yes, if the value of Qx, yes, Qx is equal to a value of I think the Qx is equal to Q maximum into 1 minus E divided by E maximum. So here we shall be, when we shall put it here Q0, we have to put it here PO. Yes, PO. Now we have two equations. First equation, second equation. See, Q maximum is known to us, P maximum is known to us, Ks is known to us. So we have two unknown, P0 and Q0. So we can easily solve the system equation. So the system of equation. Clear? That is the thing what we are going to have. We are going to have. Okay. Now this is the thing. Now we shall go our calculation. So first of all, we shall calculate the Qx, putting the numerical value and checking for unit. Again, I am saying for all calculation, you will check the unit that Qx is there. So for calculation, so now we shall first calculate the QB, then we shall calculate the QD, and we shall get the Qx value. Yes, we can get the Qx value. Okay. So this is the first. Then we shall calculate the Q maximum. We shall calculate the P maximum. Yes, Q maximum, P maximum we shall calculate. Okay. After calculating the Q maximum and P maximum, what we have to calculate? Ks. We shall calculate the Ks. So after the calculate the Ks, we are going to solve the system equation. Equation 1 and 2. By giving the value, putting the value of Q maximum, P maximum, and Ks. Yes, by the multiplication, and we shall get the P0 and Q0. Yes, P0 and Q0. Right? That is the what we are going to conclude. What we are going to do, we are going to conclude our lesson for this for today. But before going to the lesson, I am giving you an assignment. That is, which is named assignment number 1. Solve the problem discussed in the class. That means we have to totally after everything we have to do the solve the problem what we discuss in the classes, submit it through Google Class. Before the next class. Okay, so I'm asking all of you to see, be careful about the time. If you are late, marks will be reduced. And this marks will go for your class performance mark. Clear? I think so. I am clear about the assignment. So today or tomorrow, I shall because our problem is with you. You will solve it. So I shall give you and a Google Classroom an assignment so that you can submit it through the Google. Am I clear? My dear students, are you in the line or not?
Yes, sir.
Yes, sir. Ask it, sir.
Ji sir.
Okay. Now what I am doing, I am taking the attendance. In Zoom will take the attendance and he will send me the list of the student. So I be sure that you when you are logging in, your student number is there. Some information about you, information number is there. So if you have any questions, please you can ask me. Otherwise, we are going to finish. Is there any questions, please?